and count. Yeah. All right, there we go. Permutations and combinations. All right, let's just go down to the bottom here. So if we're making a toy, it has three parts: the top, the middle, and the bottom. The top can be four different colors: red, white, blue, or pink. The middle can be orange, purple, or black, and the bottom can be yellow or green. Right? Has anybody done in their math a tree diagram before? Yep. Yeah? You draw a tree and diagram it. Exactly. So a tree diagram is used to figure out how many different options there are to make something, or how many different ways you can organize something. It's good for small sample sizes. You're going to see in this one, and we're not going to use it because once the samples get big, the tree diagram gets huge, and it's kind of a messy way to do it. But we'll use it just to illustrate that point. So the top, we have four choices of a color: red, white, blue, or pink. So we draw four branches. We can be red, white, blue, or pink. This is the top. Then in the middle, okay, what's going on? The middle part, each one of those I have, how many different choices? 3, orange, purple, or black. So orange, purple, black. Orange, purple, just write PU. Black is B. You can do whatever you want. Yep, that's what we're going to do. So it could be orange, purple, black for each one of those choices. Then, so that's the middle. The bottom can be yellow or green. So each one of those has 2 choices coming off of it. Yellow or green. Yellow or green. I'm not going to write them all out. So you can see why we don't like to do tree diagrams, because they get pretty big pretty quickly. How many choices? So basically the number of choices is the number of letters, I guess, here you have at the bottom. All right? So it would be 24. If you count them all up, it's 24 choices. Yeah, there's like 1, 2, 3, 4, 5, 6 choices there, because you'd be red top, orange middle, yellow bottom, or red, orange, green, or red, purple, yellow, or red, purple, green, or red, blah, blah. I need to go through the whole thing. Okay? If you count those up, there's 24 choices. Obviously, this is not a viable way to do it. All right? Even in some, because probability used to be in Math 12 as well, even in some higher probability questions, I would still use a tree diagram, but only for small sort of samples. Anything beyond this, it's like too big. Instead, we would use what's called the fundamental counting principle. And all you do for that is you go, okay, there's my top, there's the middle, and there's the bottom. How many choices do I have for the top color? 4. How many do I have for the middle? 2. And then the bottom I have, it's 4, 3, 2. 4 times 3 times 2 is 24 choices. This is the number of choices, or options, I guess. And you multiply them together. It's not 432, it's 4 times 3 times 2. You get 12, or 24, sorry. So there's 24 different ways I could make this toy. All right, that's it. This is the kind of stuff we're going to be doing. But the wording of the question can tweak the whole thing. So we need to be careful how we read it. May I flip the page, please? Now this will be the inserts for some people. If you got a new one today, it'll all be lined up perfectly. If you got an insert, it's going to be on one of the inserts. So page 372, please. So in permutations and combinations, if you see the word and, that means multiply. All right. So if I have a quiz, and it has 8 multiple choice questions. Each question has 4 choices. All right. So each question has 4 choices. 1, 2, 3, 4, 5, 6, 7, 8. There's question 1, 2, blah, all the way to 8. How many different ways can I answer question 1? How many options are there? 4. How many options for question 2? 4. Question 3? 4. And you're going to go down the line. That's going to be 4 to the power of 8, which is 65,000. 65,536. This is why if you randomly guess on a test of 8 multiple choice questions, like true random, you just sit down and just write letters, you have a 1 in 65,000 chance of getting them all right. I like those odds. You like those odds? All right. Now, if you actually read the question and eliminate certain things, the probability will go up. But if you just randomly guessed without looking at anything, there's only one of those will have all the right answers, right? But there's 65,000 different ways you can combine all those. All right. Now, we are going to start making some numbers. We do a lot of numbers. We do a lot of letters. Later on, we'll start to do a lot of card questions. All right. If we have, well, let's talk about the digits. How many digits are there? Digits, single digits. 10. There's 10 because it's 0 to 9, right? There are 10 digits. 0 to 9, so there's 10 digits. Those digits make up all the numbers in the world. All right. If I want to make, I don't like when they do this. Odd 4-digit numbers. Okay. So 4 digits, I mark out 4 lines. It's going to be odd. For a number to be odd, it has to end with an odd number, correct? So what are the odd numbers? What are the odd digits? 1, 3, 5, 7, 9, right? How many options are there? How many numbers are odd? 5. So that means I have 5 choices. These are your number of options. I have 5 options for the last number. Now, how many options do I have for the first number? Bear in mind, is that a 4-digit number? No. So you can't lead with a 0. That's just a 3-digit number, right? So you can't lead with a 0. So the first number cannot be 0. So how many choices do I have for the first number? 9. Can the second number be a 0? Yes. Yeah. So now it goes back to 10, and then I have 10 for the other one. So if you multiply those out, you will get 4,500. There's 4,500 different ways I can make an odd 4-digit number. Okay? Is that okay? Yes. All right. Now we're going to do odd 4-digit numbers with no repeating digit. So once you use a digit, you cannot use it again. All right. So 4 digits. 1, 2, 3, 4. It's odd, so you have to pick an odd number to put at the end. How many odd numbers are there? Odd digits, I guess I should say. 5. So I have 5 choices for the end. Now, the first one cannot be 0. How many choices do you have for the first one? 8. So if you listed out all the digits, 0, 1, 2, 3, 4, 5, 6, 7, 9. Okay. I picked an odd one to put at the end. So we'll just pretend that was 1. That one's gone. I cannot have 0 at the beginning, so that's not an option. How many numbers are left? 8. There's 8 options, right? So I have 8 choices for the first one. Next number, can I have 0 in the next number? Yes, but I picked one of the other ones. So now how many options do I have? 8 still, right? Because I can't repeat. So now I picked another one. How many do I have left? 7. So that gives me 2240. So when you're not allowed to repeat, the number of ways you can arrange things decreases dramatically. We okay?
Yes.
Okay, license plates. Let's make a license plate. So we're gonna make license. Oh, I may erase this. License plates. So we start with any letter other than I or O. So your first option is it's not I or O. So how many choices do you have for that first spot? 24, right? Because there's 26 letters in the alphabet. I'm not allowed to have I or O. So there's 24 choices. Then it says, followed by, let me highlight this, followed by 3 digits, the first of which cannot be 0. So 3 digits, this one is not 0. So how many choices do I have for that first digit? 9. Yeah, so they don't say anything about repeating, so we're allowed to repeat. So these 2 digits, I have 10 choices and then 10 choices.
Why can't it be 0?
Because it can be 0. You can pick anything. You just can't have a 0 in that second position. Okay. And then we're followed by any 2 letters which are not repeated. So how many letters in the alphabet? 26. Right? No. I think they're saying now you can use, like, starting over. This is why when I write the question for you, I'll have to be very specific and clarify it. So I have 26 choices for that letter. And then 25 choices for that one. So these are the letters. Remember, this is not the number. Okay? These are the options. So you have to multiply all those together. So these are the options. So if you multiply 24 times 9 times 10 times 10 times 26 times 5, you will get 14,040,000. Yeah, but you just make it longer, right? Put one more letter, and then you multiply by 24, right? So you can make them longer, or you can start doing anything.
There's also like custom plates that have like ratios of numbers. Yeah, if it's custom,
What are you asking me this for? All right, so 14 million different ways. Is that okay? You figure out the number of options and you multiply them together. I would like you to do 1 to 5. So if you go to the assignment section, so if you scroll to where it says assignments, I want you to do 1 to 5. For the first one, don't do the tree diagram. Just do the fundamental counting principle. So we're going from Pitland to Queensville, to St. Luke's. There's our little drawing, very fancy map drawing that they gave us. There's Pitland, there's Queensville, there's St. Luke's. How many ways are there to get to Queensville from Pitland if we start here? There are 2 routes. That make sense? So there's 2. How many ways to go from Queensland to St. Luke's? 3. So how many ways to go from Pitland to St. Luke's if you have to go through Queensville? 6. 2 times 3. All right. Now, what if we say, no, we want to go from Pitland to Rutherford? How many ways to get to Rutherford?
3.
How many ways to go from Rutherford to St. Luke's? Yeah, just 1. So how many ways?
And the other way.
No, but you have to go through this way. You have to go through Rutherford.
Oh, okay.
That's what they're saying.
Got it.
How many ways to go from Pitland to St. Luke's if you must pass through Rutherford? 3. 3 times 1 gives you 3. Okay? So there's 3 ways this way. There's 6 ways that way. So how many ways are there in total to go from Pitland to St. Luke's if you can do any way you want?
12.
Yes. 12.
4 times. Oh, 3 times 6, 18. 3 times.
I can go this way,
Yeah.
in which case there's 6 routes, or I can go this way. There's 9 different ways.
18 divided by 2. You let me finish.
Okay. All right. So before I said the word and means multiply. If you see the word or, that means to add. Okay? Because so what this is saying is we're going from Pitland to St. Luke's through Queensville or Rutherford. That's why we add them together. All right. Telephone numbers. Here we go. Telephone numbers allocated to subscribers in a rural area consist of one of the following: the digits 345. So it has to be 345. How many ways can you write 345? How many ways can you write 345? How many ways can you write 345?
1.
There's one way to write 345, because if you write it another way, it's not 345. So there's one way to write 345, right? There's only one way to write the number 345. Correct? That makes sense, right? Okay. Followed by any 3 further digits. I can write any digits I want. And I'm allowed to repeat. So what are my choices there?
10, 10,
10, 10, 10. Then our magic number, or the magic word, or. What does or mean?
plus. What page is this?
Plus 373. The digit 2. So has to be a 2. How many ways can I write the number 2? There's only one way to write it. It's not one. Okay, hang on. I'll clarify that in a sec, because people always make that mistake. Just hang with me for 1 sec. Followed by one of the digits 1 to 5. So if the next number has to be a number between 1 and 5, how many choices do I have?
5.
5, right? 1, 2, 3, 4, 5. Hey. That was not me, YouTube. That was Riley. Followed by any 3 further digits. 1, 2, 3. They can be any digit you want. 10, 10, 10. Okay, so just to clarify, because every time I teach this, I've taught it in 5 years, this is not 1 over 345. This is the number 345 is one way. So these are all your options. You multiply all these numbers together. So 10 times 10 times 10 is
1,000.
1,000 plus 10 times 10 times 10 is 1,000 times 5 is 5,000 plus 1,000 is. This is the smartest class I've taught on this Tuesday, June the 7th at 2:40. All right. Are we good? That makes sense? All right. Riley's going to love this question.
What is it? Is it hockey scores?
Nope.
Am I gonna hate it?
Yep. Okay. So we're back to numbers. We're making 4-digit numbers, but this time we're doing even numbers. Evens are kind of different instead of odds. All right. So we're making 4-digit even numbers. All right. We're allowed to repeat. All right. Repeats are okay. So 4 digits, 1, 2, 3, 4. All right. What does my last number need to be if it's going to be even?
0, 2, 4, 6, 8.
0, 2, 4, 6, 8, right? Has to be one of those.
Oh, this is the one you're doing last year.
So I have 5 choices for that number. Does everybody agree with that?
I agree.
Okay. First number cannot be 0. How many choices do I have?
9.
Are we good with that?
Yeah.
All right. How many choices do I have for the second number if you're allowed to repeat?
10.
10. And then 10. Because you're allowed to repeat in this one. So if you multiply those out, I don't know what that is.
90 times 10.
That's 100 times 45. 4,500?
Yep.
Is that what you're going to say, Riley?
I was getting there.
So 4,500 different ways. Okay. That's not the interesting one. The interesting one is, what if you're not allowed to repeat? So,
Why is it interesting?
because watch. Oh,
I was thinking not interesting.
No, not you. It's the topic of
No, I heard it.
conversation. I would never say such a thing.
all right. So, if you are not allowed to repeat, you have to account for 0 by itself. All right, you have to deal with 0. So what we're going to do is we're going to say, this is 0. How many choices do I have for the end number? If I make it 0? 1. There's only one 0, right? I'm saying it has to be 0.
Doesn't that make a different possibility?
Yeah, it does.
10 possibilities. Or, no.
What are
Yeah,
you
you know what? You
talking
just
about?
keep going, it's like all the numbers.
Okay. Now, the first number, you'll see in a sec. Okay. The first number can't be 0, right? But we've sort of eliminated that. So how many choices do you have for the first number? How many? 9. Correct?
Yeah.
How many choices do you have for the second number? Good. And then 7, right? So that's 504 choices for that. Or, what does or mean?
Plus.
Plus. Okay. But the last number could be 2, 4, 6, or 8 as well, right? Which means I have 4 choices. How many choices do you have for the first number?
9. Can't be 0, 8.
Because this can't be 0 either, right? Because this one, because we use 0 at the end, I don't have to really worry about it. So I have 9 choices for the first one. But if I don't use 0 at the end, and I can't have a leading 0, that becomes an 8. You only have 8 choices. Then, how many choices do you have for the second number? 8. Because 0 comes back in, right?
Oh.
So now that can be a 0. And then the next one will be 7. So you get these 2 different sequences. So that gives you 1792. If you add those together, you get 2296. All right. You don't look thrilled. All right. Let's do, I don't know, 6 to 8, and then 10, 12, 16. Please. I'll give you a few. Is rearranging letters. Now we're gonna take the word English here, and we're gonna rearrange these into 4-letter, and we're gonna say words. And by words, I mean just different arrangements. They don't have to make sense. Okay. So 4 spots. How many choices, or how many letters are in the word English? Let's start with that. 7. Okay. How many choices do I have for the first spot if I'm not allowed to repeat the letters? Yeah, in a sec. Just give me a sec. Okay. How many choices do you have for the first letter? 7. How many for the last one? Or for the next one? 6, 5, 4. Multiply those out, you get 840. Just let me do these 3, and then I'll answer your question, okay? All right. The first letter must be an E. So the first letter has to be an E. There's only one E in the word English, so you put a 1 there. How many letters are left over now? And then 5, and then 4. That gives me 120. We're putting word in quotes, right? It's just a random mix of letters. Doesn't have to make sense. All right. First and last letters must be vowels. So what are vowels? Let's start with that. A, E, you messed me up. A, E, I, O, and U. Okay, so in this word, there's only 2. There's E and there's I. So if the first letter has to be a vowel, how many choices? 2. If the last letter has to be a vowel, how many choices? 1, because you've already used the other vowel at the beginning. How many letters are left over? 5 and then 4. So that's 20 times 2 is 40. So the more restrictions you place on it, the less ways you can rearrange these. All right. The word has to contain a G. So how many G's are in the word English? 1. If I force it to be in the first spot, I have 1 choice, right? How many letters are left over? 5, 4. Now, I didn't say G had to be there. I just said it has to be somewhere. How many different spots could it be? 4. So I could put the G there, and then it'd be 6 times 5 times 4. Or I could put it there, 6 times 5 times 4. So there's 4 different ways I can put the G, right? So you can just multiply that by 4, and you'll get, so that equals 120 times 4 is 480. Or you could think of it like this. The G could be there, or the G is there, in which case I get 6, 5, 4. Or the G is there, 6, 5. You'd have to do it for all the spaces. So obviously, as the spaces increases, it's going to be bigger. So you just do it once, and then you multiply by the number of spots it could be in. Okay? You want to know how many, what do you want to know about word? Oh, hang on. Do the rest of the package. Rest package. Okay.